Still on algebraic equations, we'll be talking about simultaneous linear and quadratic equation. Our main emphasis will be simultaneous linear equations. Now, simultaneous linear equations are algebraic equations which each equation has two unknown and are solved at the same time. The simultaneous linear equation comes in this form: ax plus by is equal to constant. The a is the coefficient of x is an unknown, y is also an unknown, then c is a constant. Alright, so these simultaneous linear equations, we are going to solve them using one of the methods of which we use in solving them. One of the methods, which is elimination method. We have elimination, we have substitution, but today our main emphasis will be on elimination method. Let's take for example. By giving all these examples, we are going to use elimination method in solving them, in solving both equations to give us both the unknowns. In the first example, we have r and s as the unknown. Look at the first equation, the second equation. In the second example, we have x and y as the unknown. X and y as the unknown. We are going to solve them simultaneously to get the unknown. In the third one, we still have x and y as the unknown. All right, let's start with the first one. The first one says 7r plus 3s is equal to 3 minus 3. So that is, let's call this one equation 1. Then the next one is 6r plus 9s is equal to 0. Let's call this one equation 2. Now, in elimination method, we will look for which one we want to eliminate. Like here, I want to eliminate r. So for me to eliminate r, I'll make both equation 1 and equation 2 r. That's the variables carrying r, the coefficient carrying r. I'll make them become the same. So to make them become the same thing, the coefficient of r here is 6. So I'll use 6 to multiply my 7r plus 3s is equal to minus 3. Everything in equation 1. Now in equation 2, I will use 7 to multiply everything in equation 2. 7 open bracket 6r plus 9s is equal to 0. Now let's bring out everything down here. We have 42r plus 18s is equal to minus 18. Then the next one will still be 42r plus 63s is equal to 0. So now using elimination, we minus. When you minus, the r goes up because they are now the same thing. 42r minus 42r gives us 0. 18s minus plus 63, which will give us 18 minus 63. We know our subtraction. 18 minus 63, it gives us 45. So we have minus 45 because it's the smaller number that is minusing the bigger number. So we have minus 45s is equal to the next here, minus 18 minus 0. Minus 18 minus 0 is still minus 18. So we have minus 18. We divide both sides to make s this to make sure s is standing by itself, or make s the subject. We divide both sides by minus 45. Minus 45. Minus goes with minus 45, and minus everything goes. So we are left with s equal to, what are we? Let's look for a number that can divide both 18 and 45. We have 9 divide here is 2. 9 divide 45 here is 5. So s is now 2 over 5. Now, if S is 2 over 5, for us to get our R, you say substitute S equal to 2 over 5 in, let's pick any equation. Let's pick the first one in equation 1. Equation 1 is 7R plus 3S is equal to minus 3. So where we see our S, we input it. So we have 7R plus 2 over 5 is equal to minus 3. So we have 7R is plus 2 times 3 is 6 over 5 equal to minus 3. Let's multiply through by 5. So if we multiply through by 5, this one becomes 35R, and plus 6 is equal to minus 15. So we have 35R, we move plus 6 over, it becomes minus 15 minus 6. So we have 35R to be equal to minus 21. Divide both sides by 35 so that we can make R the subject. So we divide both sides by 35. So our R will now be equal to, use 7 to divide this. 7 here is 3. And 7 in 35 is 5. So it means that the values of the unknown S and R is 2 over 5 and minus 3 over 5. So let's solve the second example. The second example is a fraction. We can still solve fraction. We have 5 over 8x minus y over 2 is equal to 1 over 4. Okay, then the next equation is 2 over 3x minus 3 over 5y is equal to 2 over 15. Now, for us to make this fraction to become whole numbers, we are going to multiply all through by the LCM of the denominator. Multiply through by their LCM. Okay, the LCM of 8, 2, and 4 is 8. The LCM of 3, 5, and 15 is 15. So let's multiply all through by their LCM. When 8 multiplies 5 over 8, we have 5x minus, when 8 multiply y over 2, we have 4y. And when 8 multiply 1 over 4, we have 2. When 15 multiply 2 over 3, we have 10x. When 15 multiply 3 over 5, we have 9y. And then when 15 multiplies 2 over 15, we have 2. Now, I'll just show you an example of how these fractions multiply so that you can do it by yourself. Let's see, 5 over 8 multiplying 8. 8 will cancel 8, you are left with 5. Y over 2 multiply 8. 8 here 1, 8 here, 2 here 1, 2 here 4. We have 4y. So we can solve the rest using the same format. Now, the first one, the first example I gave on elimination method, I eliminated the first variable. So now let me eliminate the second variable so that we'll see that elimination has to do with you make one variable to become the same thing so that you'll be able to work with the rest. So we'll multiply. I want to eliminate y. So I'll use the coefficient of y here to multiply this. I'll use the coefficient of y here to multiply this as well. Now we have 45x minus 36y is equal to 18. 40x minus 36y is equal to 8. Now let's eliminate our y. 45x minus 40x gives us 5x. Minus 36 minus 36. Minus gives us plus. So we have minus 36 plus 36. That's 0. You can see that y has become 0. So we have 5x is equal to 18 minus 8 gives us 10. We divide through by 5 so that we'll be able to get the value of x. So 5 divide 5, 1. X is equal to 2. So if we have x to be 2, so we substitute in equation 2 because the first one we used equation 1. So let's substitute x equal to 2 in equation 2. Recall that this was our first equation, this is our second equation. So that first equation turned to this one, first equation, second equation. So let's use the second equation. The second equation, which is 10x minus 9y is equal to 2. Where we see x, we input 2. So we have 10 times 2 minus 9y is equal to 2. That's 20 minus 9y is equal to 2. 20 minus 2. 2, this is positive 2. Moving over here becomes minus 2. The minus 9y moving over it becomes 9y. So what we have here is 18 is equal to 9y. Divide both sides by 9. Our y is now equal to 2. We can see that even if you are given fractional numbers, you can still be able to use your elimination method to get your two unknown variables using simultaneous equation. That's solving simultaneously using elimination method. Alright, the last example, they can also give you questions coming with indices. We must have the knowledge of indices so that we'll be able to solve this question. So we'll try that one as well. This is equation 1 and this is equation 2. Now that we are given this, we are going to simplify it first. Okay? We'll simplify the equation first. This is an indices with power. Okay, this is the base is 2, so let's make this 1 base 2 as well. So we have 2 raised to the power of x plus 2y. 2 raised to the power what will give us 1. We record that in these indices that 2 raised to the power of 0 will give us 1. So now our equation becomes something like this. It will now be, you pick the powers, you solve with the powers. X plus 2y is equal to 0. That's for the first equation. Now the next equation is the base is 3. 3 raised to the power of 2 x plus y is equal to, let's make 27 base 3. So it become, when it is base 3, what will you multiply by 3? That will give you a number of times that you multiply 3. That will give you 27. Recall is 3. 3 times 3. 9 times 3, 27. So we have 3 times 3 times 3 gives us 27. That's why we have it as 3 raised to the power of 3. So now this equation becomes 2x, we pick the power, plus y is equal to 3. This is equation 2. You can pick any variable you want to eliminate. In this case, I want to pick y as a variable I want to eliminate. So let me bring it down here to be x plus 2y is equal to 0. 2x plus y is equal to 3. So the variable I want to eliminate is y. So I'll multiply each equation by the coefficient of y in each equation. Okay, so the coefficient of y here is 1, coefficient of y here is 2. So we multiply, we have x plus 2y is equal to 0. Here we have 4x plus 2y is equal to 6. We subtract. When we subtract, so that y will become 0. Okay, so what we have here is x, which is 1 minus 4, will give us minus 3x. 2 minus 2 will give us 0. If you like, you can put it, but I don't want to. So we have 0 minus 6 will give us minus 6. So we'll divide all through by minus 3 so that we can have our x by itself. So we have x is equal to, minus go with minus 2. Now that we have x, let's find y. Y in equation 1. So we say substitute. X equal to 2 in equation 2. Let me use equation 2 this time. Our equation 2, recall, is 2x plus y is equal to 3. And our x is 2 plus y is equal to 3. So we have 4 plus y is equal to 3. Y will now be equal to 3 minus 4. 4 moves over, so y is equal to minus 1. So now if we want to be sure that our answer, let's check. Let's check for the indices part. 2 raised to the power of x plus 2y. Let's see if our answer will give us 1. So we have 2 raised to the power, what is x is 2 plus 2, our y is minus 1. So we have 2 raised to the power of 2. 1 minus 1 times 2 is minus 2. So we have 2 raised to the power of 0, and 2 raised to the power of 0 is equal to 1. You can see that if we apply it back again, our values of x and y, it gives us back what we are looking for. Alright, so we can make use of elimination method in solving several simultaneous linear equations. Okay, so these are the little some examples. Example with fraction, example with whole numbers, and example with indices.